For today's lesson, we're going to be working on 6.4, which is rational exponents. So essentially, we're going to be changing a radical expression into a fractional exponent instead of using that radical sign. So you can see here with the index of n, or the root n of x, is equal to x to the 1 over n power. And so this is important. This is our index, and then we have one of these x's, so that is the power on top. Here's the power of that x, or that radicand, and then the n is our index. And so we're essentially making a fractional exponent. In this case, with this example over here on the right-hand side, our power of x is m, so it goes on top of our fractional exponent, and then we have an index of n. So we're going to do the same thing. We're going to go back and forth from this, and to do that, let's take a look at our first example. We have x to the 1/6 power, and in this case, this 6 is our index, and then the 1 is the power of how many x's we have. So I'm going to write x to the first power with a radical that has an index of 6. So this is the 6th root of x. Number 2, we have a power of 2, so this is x squared inside of the radical with the index of 7. So this is the 7th root of x squared. And we can write this in other ways, but this is one way to interpret it. Our next problem here is we have y to the -3rd. So this is y to the -3rd underneath the 4th root. So again, our index is 4th. So this is a problem here because we're going to end up with this fraction. We have 1 divided by y to the 3rd inside of the 4th root. And if we 4th root the top and the bottom of this fraction, we end up with 1 over the 4th root of y cubed. Now, the beauty of this is when we have a 4th root and we want to rationalize this, we only need one more y. So this is going to be the 4th root of y over the 4th root of y, and this is just a giant 1. So we're going to multiply this across, and you'll see what's going to happen here. I'm trying to simplify this down, and I'm going to end up with the 4th root of y divided by the 4th root of y to the 4th. So I'll bring this back down here. The 4th root of y, make that a little bit better. The 4th root of y divided by just y, because what happens here is the 4th root and the 4th power, those are going to cancel each other out, and we're going to end up with this final simplification. I would definitely recommend going back and watching this one again, step by step, if you're lost. That one's a really, really good one. It's going to definitely show up on a quiz. Okay, for number 4, we have x to the 1.5 power, which is really x to the 3/2. So we have x to the 3rd power inside of the square root. So this is the root of x cubed. That's its simplified form. We can go a little bit further and recognize that this is the square root of x squared times x. And then we can notice right here that this x squared will escape. So we're going to have x squared is reduced inside of the root to just a singular x on the outside, and we're left with an x on the inside. This x does not get to leave the square root because it does not have any perfect square. Our last problem here is y to the -1/2. This is rewritten as y to the -1 over 2. So again, this is similar to number 3. Let me make sure that we have space to allocate this. We have, in this situation, 1 over y to the 1st, and this is underneath the square root. And this is going to simplify to the square root of 1, which is 1 over the square root of y. This one should be a little simpler to rationalize because the square root of y times the square root of y is just going to be y. So I end up with multiplying straight across on my fractions, square root of y over a single y. Beautiful. Okay, this is the simplified form for number 5. Okay, now we're going to write in exponential forms 6, 7, 8, and 9. The square root of 10 is, there is a single base of 10, so this radicand is 10. There's only one of them, and it is of the square root. So this is the index of 2 goes on the bottom of our fractional exponent. That's the index. And the number of 10s that we had was 1, so it's going to be 10 to the 1/2 power. We have 2x cubed inside of a square root. I think we can do some simplification first. Now we don't have to, so we can end up with this first. We can have 2x to the 3rd power divided by 2. So this is really what it's interpreted as. We have 2x raised to the 3/2 power. If you wanted to go a little bit further, which it's up to you to do that, you could recognize that this is 2x squared times 2x inside the square root. Cancel one of those out. You still end up with the same thing, to be completely honest. But this is 2x times 2x to the 1/2. There's another way to write it as well. Still ends up with, it's very cyclical, still ends up as 2x to the 3/2 power if you're working that one out. Okay, number 8, we have a squared underneath the 3rd root, so we have a to the power of 2 divided by 3. The squared or the power goes on top. This is the power of our base, and then we have the index is our divisor in the fractional exponent. Our last one here is we have c raised to the 2/4 power. Again, the power is 2, the index is 4, and we are going to reduce this to c to the 1/2 power. Finished. And that's going to actually just be the square root of c. Our last 6 problems that we're dealing with is simplification. We're going to simplify this. I'm going to rewrite this as the cube root of 216. And if you recognize this, 216 is a perfect cube, so we end up with just 6. If you want to see why, the reason why this is we have the cube root of 6 cubed. Cube root and the cube cancel out. We're left with just a base of 6. We have 7 raised to the 1/2 power times 7 raised to another 1/2 power, and we're going to follow the laws of exponents and state that anytime we have 2 bases that are the same, we are going to add the exponents if the bases are multiplying. So this should just be 7 to the 1st, which is just 7. On 12, we should do a little bit of simplification. I'm going to rewrite this as 3 to the 1/3 power times 3 squared. You get that from 9, raised to the 1/3 power. From our laws of exponents, again, if we raise a power to another power, we have to multiply the powers. So I'm going to end up with 3 to the 1/2 times 3 to the 2 times 1/2, which is, or 1/3, I'm sorry, which is 2/3. So let me say that again, 3 to the 1/3 times 3 to the 2/3. And then we're going to do the same thing we did before, which is if we're multiplying the same bases, we add the exponents, and we end up with 3 to the 3/3, or just 3, because that's 1, first power. Alrighty, we're going to have to reduce a little bit on our next one, but we're going to rewrite the top, or the numerator, as x to the power of 2/4, because the power is 2 and the index was 4, over x to the power of 3/4. Again, the power is 3 and the index was 4. And since we have another law of exponents, we are going to have to subtract the powers due to the bases dividing each other. So I'm going to rewrite this as x to the 2/4 minus 3/4. And we are going to reduce that down to x to the negative 1/4. And this is as far as we can go. We'll end up in a cyclical pattern again, just like we did up above with number 7, if we keep on working this one out. So this is where I'm going to leave it, as x to the negative 1/4 power. Number 14, I'm going to rewrite x to the 6th as x to the 6th over 9, because 6 is a power, 9 is the index, times x to the 1st, this is one of the x's, so x to the 1/3 power. I'm going to reduce 6 over 9 as 2 over 3. And so here's where I end up. I end up with x to the 2/3 times x to the 1/3. And that's going to get me x to the 3/3, or just x to the 1st. Our last problem here is 15. I have the square root of 5. My base is 5 and it's raised to the 1/2 power. I have 1, 5, and it's underneath the square root, so this is a 1/2 power, times another base of 5. There's only one of them in the 4th root, so power of 1, index of 4, so 1/4 power. And if I multiply these bases, I need to add the exponents. So I'm just going to rewrite this so they have common denominators. So this is 2/4 plus 1/4. And so what I'm going to end up with is 5 to the 3/4. Now I'm going to go above and beyond. This is where we need to stop right here. But just in case if you want to see it, this is really the 4th root of 5 cubed, which would then turn out to be the 4th root of 125. So that's another way to look at this, just so you can see it. All right, this was a good review of how to turn a radical into a fractional exponent, and vice versa, a fractional exponent into a radical. If you have any questions, please feel free to reach out and ask either one of us teachers a question. If not, email me and I'll get back to you. Have a good day.